All right, let's keep going with our special factoring. So looking at A, well, what we should always do is you want to see is there anything that we can factor out first. That should be our number one. So I do see that we have so 2 and 8, right? So I can factor a 2 into that. So let's do that first. So we'd have 2, start a bracket, and what we have left is x squared minus 4. And do you see what just popped up there? That is a difference of squares, right? There's two perfect squares there. So we're going to factor just this part now. So that 2 just hangs out front. So we've got 2. And then we can just throw down our brackets. And now we take the square root of x squared, so which is x, right? So they both get an x. And then the square root of 4 is 2, so they both get a 2. One's minus, one's plus. And there you go. That's it. All right. Moving on to the next one. So let's look at this. So what's common to 12a and 27? Okay, well, what's common to 12 and 27 first? So that would be 3. And then a and a cubed, so a. Now we'll start a bracket, and we'll see what we got left. So 12 divided by the 3 we took out is 4. And then minus 27 divided by 3 is 9. And then we're left with a squared. Well, what a coincidence. We now have a difference of squares, right? Difference, we're subtracting, and 4 is a perfect square, so is 9, so is a squared. All right, so let's factor that one. So now we've got 3a just hangs out, but now we can throw our brackets down. Square root of 4 is 2, so they both get a 2. Square root of 9 is 3, so they both get a 3. And then square root of a squared is a, so they both get an a. And then one's minus, one's plus. Okay, let's look at C. So now in this case, so again, we should always see is there anything we can factor out? And yes, there is. So what's common between 20 and 5? So that's 5. Oh, sorry. And then let's look at the m. So what's common between m cubed and m? Well, that would just be m. And then what's common between n and n cubed is just n. And then start a bracket. And now 20 divided by the 5 I took out is 4. And then this would be m squared. And then the n is gone, right? Minus. And now we factored out the m, right? So there's no m there, but there is still an n squared. Now I can see it that it happened again. So we've got perfect square, right? Perfect square, subtraction, and then perfect square. So just write this one more time. 5mn, n. And then I'm just going to write down my brackets. So then square root of 4 is 2. So they both get a 2. Square root of m squared is m. And then square root of n squared is n. Whoop. And then one's minus and one's plus. All right. So now in this one, again, let's see what we can factor out. So in this case, what's common to 48 and 3? Well, that would be 3. Start a bracket. And then 48 divided by 3 is 16. And then still have y to the 4. And then minus 1. All right. So now you might be saying, okay, no, this one's not the perfect difference of squares, is it? Because, we've got 1 there. But it actually is, right? So this is one that people always miss. So 16 is perfect square. Y to the 4, right? Even. Any even power would be a perfect square. And then 1 itself is 2, right? Because the square root of 1 is just 1. But yeah, people miss that all the time. So let's carry on. So now we've got 3. Throw my brackets down. Square root of 16 is 4. So they both get a 4. Square root of y squared is y to the 2. So they both get y to the 2. And then square root of 1 is 1. So they both get a 1, right? So 1's minus and 1's plus. Now you might be saying, okay, cool. That was exactly everything we wanted to do. But look what just popped up. That's another difference of squares, isn't it, right? 4y squared and 1, right? This one's not. I can't factor the second one anymore, but this first one I can. So we need to factor this one again. So let's do that. So we got 3. And then I'm just going to throw my brackets down. And I'm just looking at this now, right? So square root of 4 is 2. So they both get a 2. And then y. And then 1 and 1. 1's minus and 1's plus. And then we still add this last part here. So then this was 4y squared plus 1. And now none of the rest of these factor, right? Like even though this is a difference now, 2 is not a perfect square and y is not a perfect square. So that's as far as we go. And this one isn't subtraction, so we can't factor that.